Okay, so in this video, I'm going to defend the portability claims that I made regarding this approach of accessing the GPIO controllers using Zephyr, right? So let me switch here so you see what I have in my hand. So over here, I have a Nordic semiconductor device. This is nRF9151. And without changing anything in the code except some few configuration changes in the build system, we are going to upload the same firmware onto this board and we will see it work. So I'm going to go to the desktop, and then what you have to do first of all is to right click and then do clean, so that it's going to clean all the build artifacts that were created for the STM32 build that we did in the previous video. And then you can come to configure, you go to change board, you wait for it to load, and then you look for your particular board. So my board here is nRF9151, so I choose this. And then remember to also change the workspace. So you go to configure, change West workspace, and then you choose Nordic here. Once this is done, you click on build, and then we wait for the build to complete successfully, hopefully. It's still building. Yes, it is done building. So now I will connect my cable to the Nordic semiconductor board that I was holding, and then I'm going to flash this firmware onto the board. Then I'll switch for you to see. So it has been flashed successfully, and I can come to the instructor only view, so you can see that this is a different board, a different manufacturer, and we still got some LED blinking. Why? Because in the device source tree, or sorry, the device tree source for this particular board, there is also an alias called LED, whatever LED number we are using on the desktop. So let me see. So it means on this board in the device tree source, there is also an LED3 that is defined, right? So let me change to, let's say, LED 15, and let's see what's gonna happen. If I change to LED 15 and then I try to build, it fails at compile time. And this is the beautiful aspect of using these macros that have been defined, right? So what happens is that during the build process, it has checked the device tree source for my board, and it has realized that there is no alias for LED 15. So it's not even going to compile in the first place, right? So these are security features that have been put in place by Zephyr to ensure that you cannot do something on a board that doesn't even support that. As far as it knows the board, it's going to look at the device tree source, and if the alias you are using isn't there, it's going to fail. And this is also proof of the fact that I said yes, something like LED 15 isn't something we defined on our own, but some way, somehow, it is able to work because the build system looks for the device tree source, generate a .h file, include it in our project, and then the project compiles successfully if everything is okay. So if I come and I change this to LED, let's say 1, because there is LED 1 in the device tree source for my board, is going to compile. You see it has compiled successfully, and I can flash this code onto it. And if I point to the camera where you can see me, now you see that a different board. So previously it was the LED up, now it is the bottom one that is blinking. All right, so these are some of the compile time guarantees and safeties that Zephyr introduces to also ensure that your code is correct, and once everything is correct, that portability claim is also going to be given to you. Thank you very much for watching this, and I will see you in the next video.